This is Suvarchala, working as an associate professor, Department of Computer Science and Engineering at Institute of Aeronautical Engineering College. In this session, I'd like to discuss some problems related to transaction management, which were included in the tutorial question bank of IARE for students. As earlier sessions explained, tutorial question bank consists of three parts: Part A, Part B, Part C. Part A, short answers, which can be written based upon the previous lectures, and Part B also consists of long answers, but most of the questions are descriptive questions and can be easily answerable based upon the lectures already done on this concept. So some of the problems and will be solved under Part 3 questions as a part of the transaction management concept. Transaction management means it includes transaction concepts, concurrency control, and recovery process also. So we'll consider the first question. Consider the following transaction T1, T2. You observe in case of first transaction, Q data item Q was read, and if P is equal to 0, P and Q both are read, and P is equal to 0, Q is incremented and write Q. In the transaction 2, and both are reading again, but if Q is equal to 0, P is updated. So what is the question here? We have to find any non-serial interleaving of T1, T2 for concurrent execution leads to a serializable schedule or non-serializable schedule. So here, if you observe here, the two transactions are dependent on one depends upon the other, because if the transaction 1 earlier completes, written by transaction 1 Q item is going to be read by T2, or T2 earlier, the updated value of P by T2 will be considered by T1. So we have to consider the solution and whether it is conflict serializable or non-conflict serializable. First, we are supposed to know what is conflict. Two or more actions are said to be conflict if the actions belongs to the different transaction and same data item. At least one of the actions is write operation and the actions access the same object or same data item. That means the two operations must belongs to different transaction on same data item, but one of them is at least write operation. So schedule S1 and S2 are said to be conflict equivalent if these schedules S1, S2 are considered as a conflict equivalent. Both schedules involve the same set of transaction and order of the each pair of the conflict actions S1 and S2 are the same. So conflicting actions means if it is conflict, we cannot interchange, and we can interchange non-conflict instructions so that we will get conflict serializable schedule. So all these things were discussed already in the lecture related to this conflict serializability. So a schedule is said to be conflict serializable when the schedule is conflict equivalent to one or more of the serial schedules. So non-serial interleaving of T1, T2 for the concurrent execution leads to a schedule that is not conflict serializable. It's not conflict serializable because write operation performed by one of the transaction is used by the some other transaction. So interleaving involves at least one conflict instruction. So in the given scenario, there are two possible serial schedules, T1 followed by T2 or T2 followed by T1. In both serial schedules, one of the transaction reads the value written by the other transaction as the first step. Therefore, any non-serial interleaving of T1, T2 will not be conflict serializable. Okay, it will be conflict. Why? Because the conflict set of instructions will be there. Fine, coming to the next question. Analyze the following concurrency control protocol, ensure both conflict serializability and freedom of deadlock. So all these things are already discussed in the respective lectures. Two-phase locking protocol, timestamp ordering protocol. In these two protocols, timestamp ordering protocol is both conflict serializable ensures conflict serializability as well as freedom from deadlocks. But two-phase locking protocol possibility of under facing deadlock problem actually. That is, this timestamp ordering protocol is conflict serializable as well as free of deadlocks actually. Why? Because in case of two-phase locking protocol and locks are going to be implemented on data objects. So that's why one transaction may be waiting for the other transaction to be released the locks on the data object which is used. Same data object is used by the other transaction. So during this process, deadlock occurrence may be possible actually. So that's why two-phase locking protocol guarantees serializability, but it doesn't guarantee free of deadlock. Whereas timestamp based ordering protocol guarantees both serializability as well as deadlock free because non-lock concurrency control method is used by this timestamp ordering protocol. So deadlock cannot occur. No transaction ever waits for other transaction to be complete. Of course, some other problems might be there. So that's why answer is timestamp ordering protocol. Coming to the question 3. So question 3, suppose that we have only two types of transactions, T1 and T2, and the transaction preserves database consistency and when run individually. We have defined several integrity constraints such that database server executes any SQL statements that bring the database into a inconsistent state. Fine. Assume that database management system not perform any concurrency control mechanism. There is no any concurrency control mechanism by database management system software. Then we supposed to give transactions T1, T2 that satisfy all these conditions yet produce a database instance that is not the result of serial execution of T1, T2. Yes, to make the database always in a consistent state, programmer can also introduce certain constraints while execution of the transactions. For example, if you are transferring the funds from one account to the other account, then some of the balances of the two accounts must be equal before transaction, after transaction, so that if any inconsistency arises, it can be aborted actually. Like that we can do it. Or in other way, another example of schedule can be T1, T2s are going to be access various different data items and there may not be any conflict instructions on same data object having one of them as a write actually. In such case also any non-serial schedule also performs perfectly actually. Next question, suppose that there is a database system that never fails. Analyze whether recovery manager required for the system. Yes, even it never fails. Even in this case, recovery manager is needed. Why? Because even database system doesn't fail, but a transaction may fail. Transaction may be aborted. Transaction may be rolled back. So that's why even in case of database system that never fails, assurance is there, but recovery manager must be available. So recovery manager must be available to perform rollbacks of the aborted transactions. So transaction failure may be various types of failures are there. So even though there is no database management system failure, there may be transaction failures, there may be some hardware device failures will be there. So that's why recovery manager must be there. Coming to the next query, next question. Consider the following actions taken by the transaction T1 on database object X. Read X, write X, read Y, write Y. Now the questions are given example of another transaction T2 that if run concurrently transaction T without some form of concurrency control could interfere with T1. So in this example, if the transaction T2 performed write Y before T1 read Y, then T2 will be aborted. So the value read by T1 would be invalid and abort would be cascade to the T1. That is T1 would also have to be aborted. So that's why the question, the example of transaction run concurrently without some form of concurrency control, then aborting of one transaction may lead to the abortion of other transaction. That is, it will be cascading aborting transactions may result actually. The second question is explain how the use of strict two-phase locking protocol prevent interference between the two transactions. Because what is strict two-phase locking protocol? A more stricter version of basic algorithm of two-phase locking protocol is unlocking is performed after the transaction terminates. Till then, it will whatever the keys are locks are acquired by the transaction, and the locks are going to be get released. That is, unlocking can be performed only after commit of the transaction. That is, commits or aborts of and rollback transaction executes, then only the respective locks are going to be released. This is the most commonly used algorithm in our most of the database management system, commercial softwares. So that's why we may not get any problem of interleaving transaction problems. So that's why strict two-phase locking protocol requires T to obtain an exclusive lock on Y before writing it. So this lock would have to be held until T2 committed or aborted. So this would block T1 from reading Y until T2 is completed. So there would be no interference in such cases. Similarly, the third question is strict two-phase locking protocol is used in database management systems. Just now I told you, give two reasons for its popularity. Strict two-phase locking protocol uh, used in many commercial software systems, database software systems. Reasons are it ensures only safe interleaving of the transactions. It ensures safe interleaving of the transactions so that the transactions are recoverable, and it avoids cascading rollbacks or cascading aborts. Another reason may be that strict two-phase locking protocol is very simple and easy to implement. Lock manager is also needs to provide only lookup for the exclusive locks and an atomic locking mechanism. So implementation of lock manager is also a little bit easy. That is same as semaphores, we can implement them actually. So that's why it is used in most of the commercial database management system softwares. And the question 7 is having the catalog relation is the transaction that adds new part to the supplier catalog and transaction that increases the price that supplier charges for a part. In these two cases, what is the isolation level has to be considered. So isolation, when we are considering SQL support for isolation levels and the two access modes for total of 8 combinations. So two access modes, read write, and isolation levels are 4. So combinations will be 8. Each combination implicitly defines a class of transactions, and the following questions refer to these 8 classes. For each 8 classes, describe the locking protocol that allows only transactions in the class. Based upon these 8 classes, one of the classes it will come under that. So which level can be easily identified by us. So the first question is the classes serializable, repeatable, read and read committed rely on the assumptions that other classes obtain exclusive locks before writing the objects and hold exclusive locks until the end of the transaction. So that means totally A, B, C, D 4, E, F, G, H 8. 8 are there actually. So first we supposed to understand these 8 combinations. Based upon these 8 combinations, we can answer the questions of the 8 as well as the questions of the supplementary question. So what are these 8? The first combination is serializable read-only. If it is serializable read-only, strict two-phase locking protocol includes locks on set of objects that it requires to be unchanged. So no exclusive locks are granted. This is the first one. Yes, serializable. Second one, serializable read-write. So serializable read-write means strict two-phase locking protocol including locks on set of objects that requires to be unchanged. Right? So this is the second one. The classes, various classes, 8 classes we specified now. This is the second class. Third class, repeatable read, read only. So in that case, 2PL only locks individual objects, not set of the objects. No exclusive locks are granted in this case. Similarly, repeatable read, read write. Individual objects only, but not set of objects granted by the 2PL. Read committed, read only. Obtains exclusive locks before writing objects and hold these locks until the end of the transaction. Shared locks can be obtained before reading object, but these locks are released immediately. After reading the data, the locks are going to be released. Another class is read uncommitted, read only. Another class is read uncommitted, read write. These are the 8 combinations of isolation levels. For each of these 8 classes, these are the locking protocol allows only transaction in the class. So that's why the 2PL, what are the things are allowed in these 8 classes were given now. So what is the second question? Second question is, consider a schedule generated by the execution of several SQL transactions. It is guaranteed to be conflict serializable, to be serializable, or to be recoverable. So if you don't know, if you do not have any requirements for the access mode and isolation level of the transaction, then they are not guaranteed to be serializable, conflict serializable, or recoverable. So that's why if you do not have any requirements for the access mode and isolation level, we cannot guarantee. So that's why we supposed to have the requirements of the access mode as well as the isolation level. Then only these guarantees of the conflict serializability or recoverability can be considered. Coming to the third question, consider a schedule generated by the execution of several SQL transactions, each of which has read-only access mode. Consider the schedule given by the execution of several SQL transactions, each of which is having read-only access mode, and it is guaranteed to be conflict serializable, to be serializable, or to be recoverable. So access mode is specified. A schedule generated by execution of several SQL transactions, each of which is read-only access mode, would be guaranteed to be conflict serializable, and recoverable. Why? Because it doesn't consist of any write statement, no? It doesn't consist of any write access. So that's why write access mode is not there. So that's why such type of executions of transactions guarantees conflict serializable, and recoverable. So please observe read only. So read only means WW, read write W conflicts are not going to be arise, no. So that's why in such cases it's possible. Third query is, consider a schedule generated by the execution of several SQL. Third query is, consider fourth one. That third question means fourth question. Consider a schedule generated by the execution of several SQL transactions, each of which is serializable. Isolation level is serializability. Okay. So isolation levels are 4 and access modes are 2. Read, write access modes. So serializable isolation level, is it guaranteed to be conflict serializable, to be serializable, to be recoverable? So the question is, schedule generated by the execution of several SQL transactions, each of which having serializable isolation level, would be guaranteed to be conflict serializable, and recoverable. Why? Because the isolation level itself is serializable. So isolation serializable means it follows a strict two-phase locking protocol. So that's why in such cases our all transactions done by SQL are guarantees conflict serializability and recoverability. The next question is, can you think that of a timestamp based concurrency control scheme that can support the 8 classes of SQL transaction? So timestamp locking with wait and die or wait and wounded wait would be suitable for any serializable or repeatable read transactions. Timestamp locking protocol undergoes these two uh, problems, that is wait and die or wound and wait. So that's why if any locking protocol having these type of options, then it may be suitable for any serializable or repeatable read transactions, because these follow strict two-phase locking protocol, just like your 2PL only. So that's why this could be modified to allow read committed by allowing the other transaction with a higher priority to read the values changed by this transaction. As long as they didn't need any override changes, it works well. That is, read committed transaction can only be the read-only access mode, so they can read from any timestamp protocol also. That means 8 classes are going to be easily mapped with the timestamp locking protocol, provided if it is having with the wait and die or wound and wait, then it may be suitable to serializable or repeatable reads. Related to those combination of the classes can be mapped actually. So this is the process of considering the respective conversion of or checking the isolation level as well as the respective combinations of access modes. If you are getting this question, what is the update actually? Update means the salary is going to be incremented by 10%, where EMP name is Santa. So give an example of query that would be conflict with this command if both were run at the same time. Conflict means we are updating. So if we are updating means we are writing here. So if any transaction having a read command on salary where ename is equal to Santa, then that will generate a conflict. This is writing and we are reading here. So reading of the same, we are writing of salary for this tuple. So for the same tuple, if you are reading, if any other transaction, then for example, select salary. Let us assume that this is the query. Select, even reading, even write is also may be there. Again, if you are writing also, for example, select reading. If you are using reading statement, select sal from our, let us assume that EMP, where ename is equal to Santa. If this query is there, it creates a conflict. Or it may be any update command also. If you are using any update, let us assume that update salary of Santa or increase salary of Santa by 500. One more write is there. Such transaction also is a conflict transaction for interleaving process actually. Okay, this is the first question based upon the access mode, read access, write access mode. Explain what could go wrong and how locking tuples would solve the problem. So locking tuples means if any such type of updations are there, conflicts are there, the interleaving must be done in such a way that these conflict schedule instructions may not come side by side. Time ordering can be properly done. So give an example of query or a command that would conflict with this command such that conflict could not be resolved by just locking individual tuples or pages but require index locking. So a query, just now I told you the updation. So query or a command that would conflict with this command. Replace means update command. So again, if the update command is there on same attribute, and then if the condition is not going to be specified, EMP must be indexing must be done. then in such cases it can be possible actually. So by using this process of considering the entire operations or SQL queries, access modes, as well as we are going to consider isolation levels as well as the access modes. So one more question problem is there in the B part also. Consider the schedule S1, R3 of Y, R3 of Z, R1 of X, W1 of X, W3 of Y, W3 of Z, R2, R1, W1, R2, W2, R2, W2. Here the number indicates transaction. Let us assume that. R3 means transaction 3. Read of Y in transaction 3. R3 of Z means read of Z in transaction 3. Check whether the schedule S1 is serializable or not. If it is serializable, write its equivalent serial schedule. So when you are using this, we are writing T1 transaction, T2 transaction, T3 transaction. So we have to consider first R3 of Y, that is Y we are reading, and R3 of Z we are reading, then R1 of X, W1 of X, W3 of Y, W3 of Z, R2 of Z, R1 of Y. Like this you have to write. Then we will get the interleaving of the transactions of T1, T2, T3 under these schedules. I'll explain by taking another example here. Now let us assume that 3 transactions are there. T1 consists of R1 of X, R1 of Z, W1 of X, reading Z and writing X. Transaction 2 consists of reading of ZY and writing of ZY both. Transaction 3 consists of reading of X, reading of Y and writing of Y. So one schedule is given like this. So if this is the schedule, possible conflicts occur when T1 writes, for example, when you would like to get a serial schedule, conflict instructions must be checked by us. So these two can be interchanged, or these two can be interchanged, it will come down. These two can be interchanged, it will come down. So this can be interchanged and it will come down. This can be interchanged because on different data items. Up to this, no problem to us. Now we got here T1 followed by T2. Then we have to check. So what are the transactions can be interchangeable, conflict serializability. So however, T3 does not write X. So this is, we are not writing any X here. So interchanging is possible. So T3 can be read and write Y before T2 writes Y. So this schedule can be converted into a serializable schedule. Please observe we are using write X. After writing, anyway X is not used by T2, no problem to us. And T3 and it is reading X. After that it is writing, but it is not writing, no problem to us. Y is written by T3 before reading by the transaction 2. So no problem here actually. So this is schedule is serializable because there is no cycles you can consider. In other way also you can interchange, as I told you, you can interchange these two and we can interchange these two. I'll get like this R2 of Z can be considered here. When we are considering here, R2 of Z and R3 of Y can be interchanged because both are different. So it will come like this, W3 of Y, then R2. That means first T1 be completed, then T3 will be completed, then T2 will be completed. So it is a serial schedule only. So like that we have to get again, we have to write R1 of X, another schedule was given here. This schedule is non-serializable and major conflict. Why? Because here it is writing X. The X which has been written by X we are going to consider that transaction 3 is going to be overwritten here. So X is writing, before writing transaction 3 is reading Y also. Y is updated by our transaction 2. So that's why there is a conflict when we are comparing them actually. So like that we have to consider the process of implementation of serializability, or how to check the schedules are serializable, interleaving of the schedules proper way, so that there may not be any inconsistency in database, so that the database perfectness will be maintained or ensured by the respective transaction management component. Thanks for watching.
Like, share and subscribe. Hit the bell icon for more updates.